Hey guys, welcome back to another episode of Simuleos, the channel that can never seem to quite start on time. So today, we're going to continue what we did yesterday, as far as working on the sorting algorithms, right? I figure, yeah, pretty much everyone's seen a sorting algorithm before, so this might not be that entirely interesting, but at the same time, there are a number of things that I want to get done, just, I want to try a bunch of sorting algorithms. The way I see it, once the visualization aspect of things are done, probably today, maybe by the end of tomorrow, then we just have to do a bunch of sorting algorithms, and this shouldn't take too long. I think we should be able to finish that in one day, so we'll probably be finishing this Thursday or Friday my time, and let's see, it's already Wednesday my time, so I think we're right on track to do that. So then once we're done with that, I think the next thing that we're going to do is, I think we'll call it for 2016 after that. I might do like an extra super special stream doing something over the weekend or something, but I don't know, I haven't decided yet. But basically once this is done, it'll be the last simulation of 2016. I'm quite looking forward to it. I'll make a YouTube video on it, and that will be that. I would like to say before continuing that this year's been quite good for both Twitch and YouTube, and I'm very happy with how far our channel has kind of come, Sure, I know I've been doing Twitch for like a year and a half now, and I basically get up almost every morning, and yeah, I've been more or less relaxed lately, where I've been kind of focusing more on YouTube than Twitch, but I mean, I still get up at 5 most mornings to do this stream, and it is a little bit tiresome, but that's okay. I'm quite happy with what I've learned and what we've been doing here, so that's good. So I'm very happy with how this channel has progressed and how my YouTube channel has progressed. Like, this year has been quite good for a number of different things. However, in general, if you ask someone how 2016 has been, they will tell you that it's been quite a bad year. That 2016 could not have been that much worse. Now, I disagree with this on principle because, yeah, some years, we have like World War II going on or something like this, so it's not the worst year ever, but it could be a lot better. So basically, the idea behind this particular algorithm, the one that we're doing right now, is I wanted to kind of sort all of the bad things that happened in 2016 by using an algorithm known as worstsort. Now, obviously, we have to give them all kind of arbitrary values as to what each event means, So it could be that some events are, I subjectively have to rate them at some point. So that's something that we have to consider. And I might ask for you guys' help tomorrow in finding that list, because I haven't quite found a good list of all the bad things that happened in 2016, but that's okay. I'm sure there's one out there. I just need to keep looking for it. But there are a few top 10 lists of bad things, so I figure if we can concatenate a few of the top 10 lists, we should be okay, I think. I hope. We'll see. Anyway, so we're going to go ahead and CD into the appropriate directories, CD projects, Simuleos, and of course, in this case we want to do visualization and Cairo. Okay, we're going to do the same thing over here. CD projects, visualization, Cairo. Now, what are we going to do? We do a quick ls, and let's just run the make command. Okay, and now we're going to run, yes, okay, so it's running. Let's go ahead and run Mirage, and let's take a look at what we have from yesterday. So yesterday, we officially made this guy, and I know it doesn't look like much, but it takes some time, right? So the idea here is that we're drawing a line to represent every element in our box, right? Okay, so now we have to think about things a little bit differently. Sorry for the yawn, guys. Okay, so what do we need to do? Well, there's one thing that we have failed to do, I suppose, and that would be we have failed to take into account a particular case for this scheme. Okay, so what do I mean? Let me go ahead and go into Cairo visualization.cpp, pop down here, and there's one thing that I just kind of said, but we do kind of need to address. So it says if bar step is less than 1, this means that, first of all, the number of time steps between each bar being drawn is less than 1. Okay, so this means that more than 1 bar needs to be drawn every time step. Okay, so that means that we never get into this this case where I mod bar step equals 0, because bar step is, well, in this case, less than 1. So it's got to be 0, right? Because we said bar step was an integer. Now what we can do is we can go up and we can cast bar step. Where is it? We can change bar step into a double, and then we can cast it into an integer, and then we should be okay. But this doesn't quite solve the problem. The question is, what do we do if we have more bars to draw than we have time steps, right? And I guess the easy solution here is to go ahead and draw all of the bars at once. So we just grow each of the lines at that time. So let me see. But the problem with this is the bar graph. Let me see. What do we do? Vector of integers for I less than draw frames. What are we doing here? We are drawing. Where's our array? 1 second, I have to see something. Animation, array, animation, grow line. Oh, I see. So it's in that grow line function. I see. Okay. So we're growing the line. Animation current frame, bot top, line color. So bot is going to be equal to array.size, animation, shoot, I really should have paid more attention to this. Animation resolution x times 0.5. Bot.x is going to be current bar. How do we get current bar? Plus plus, okay. Hey, happy little rat. So we say current bar times x range divided by array.size, x range minus resolution x times 0.5. Okay, so we have the bottom bar and the top bar. Okay, 1 second, I have to think here. So bot.x, bot.y, that's what I care about. So array of current bar. Okay, good. So we're going through each of the current bars. So current bar is going to be our iterative value for our array. Good. That's what I thought, but I just had to make sure. So what does this mean? Well, basically, the way I see it is we should draw the entire plot in one frame. If, well, not one frame, but let me see. Now, I say we should draw it all in one frame. I think that'll look better in the end. So let's go down here, and let's go ahead and comment this out, and let's draw everything in one frame. Let's go this, that. Okay, so now what we're going to do is basically, well, copy what we have down here, because it's not really that big of a deal. And let's see, grow line, animation, time divided by array.size, animation current frame. Okay, so basically what we need to do then is we need to grow each of the lines with a time of 0. So let me see. Bot.x, yeah, I think we can still take the bot.x stuff that we have down there. Bot.y should be about the same. Top.x, top.y, all that should be the same. So in some sense, we should just be able to take this entire for loop, and let me see. Instead of going from draw frames, we go to, let me see, not draw frames, but just go through each of the individual. Yeah, so we should be able to do something like this. Sorry about that, I'm really kind of scattered for some reason, but that's okay. Hey guys, so we're going to say for, and I suppose we should do size key, I equals 0, I less than array.size, I plus plus, pop this down here. Okay, so we're going to go through each of the elements, and basically we're going to create the top, the bottom, like we did before, and we're going to grow the line for each of these bars. That's all we need to do. And then we should be okay to go. So in this case, we'll draw everything in one step, and we should be, I think, good to go from there. So let's just go ahead and grab these guys from down here. Yeah, we could probably grab up to there. Okay, so let's see, grow line here, and we're going to change this to a 0. Well, you're doing a sorting algorithm? Okay. Yeah, it would. I'm sorry, I'm working on this. So animation current frame, number of frames. Let me see, what's number of frames? Oh, wait. Number of frames. Oh, okay, so we're drawing it on all the frames. Okay, good. So then we say bot, top, line color. Okay, so now let's go up to VI visualization test, I believe. Yep, .cpp. And what we want to do is we want to say, let's see, vector origin. Let's change this to 1000, like we had last time. And let's make that. Okay, so it says we currently have a problem. That's because these are not defined in that scope. That's fair enough. Let's go back over here to Cairo visualization.cpp, pop down to the bottom, and let's scroll up here and see what we got here. So what I want to do is I want to define these guys above this if statement here. So let's pop down here. And now let's go ahead and remove a couple lines. Well, let's leave that line. And let's remove this line here. Okay, give it a second to do its thing. Seems to be making something. That's good. But then we have floating point exception. So let me see. Let's go ahead and go into the make file. Let's go down here and let's not run it. Make that. Now what we want to do is run GDB. What is it going to be? It's going to be visualization test. That should be right. Oh, that was not right. It should be GDB. And now let's run. And then we'll run a backtrace. Okay, yeah, so it says basically the same thing. It says 499. Yep, 499. Oh, that's because I need an else. Oh, that's gonna be a pain, but that's okay. Okay. So what we're gonna do then is just kind of edit this up a little bit. So let's go here, put num frames here. Okay, let's go down here, remove this. Let's go here and I guess I'm just gonna bring this down to the bottom line. Something like this. So let's go ahead and do a Control D. Yes, make. And now let's go ahead and run visualization test. Give it a second, and then we'll run Mirage. Oh, sorry, Mirage. Okay, it didn't draw anything. That's okay. I implemented a string class we were talking about. It only works 64-bit little endian architectures. But oh well. Wait, little endian. What does that mean? Sorry about that, I'm not so familiar with it. Okay. So I see the problem here. The problem is that instead of current bar, we should be doing I. Let's go ahead and fix that. Nope. 1 second. Make. Okay, now we're gonna run visualization test, and then we're gonna run Mirage. Oh, oops. Give it a second. Okay, well that was also an issue. Let me see. So it shouldn't be current bar, it should be I. Any other case where I use current bar? Nope. Okay. Make. Visualization test. Mirage. Okay, give it a second to do its thing. Then we're almost done with this particular segment stuff. I don't know. Okay, good. So we drew all of our lines. We drew 1,000 of them, so I think this is probably fair enough. Now, what are we going to do next? Well, next I'm going to go ahead and delete these lines over here. So get these guys down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now, what are we going to do next? Well, let's see. What do we have up here? We're currently drawing everything on all of the frames, right? However, I think we should probably have an end frame in sight. So let's see, double time, X array, X range, Y range, bar graph. Yeah, so we should probably have an X range in sight. So let's see, what do we have here? What I would like to do is I would like to add in an additional element in here. And this is going to be the end frame, basically. So the start frame, wait, let me see. Do we already have this in bar graph? Let me see, what do we have? Clear context, draw array. No, we do not. Okay, so let's go ahead and add this in. So we need basically a start and end frame with bar graph. And I think that should be good. Yeah, we need a start and end frame. Little/big endian is how things are laid out in memory. With big endian, it goes most significant byte, least significant byte. With little endian, it is least significant byte to most significant byte. And, okay, yeah, so this must be, it's an architectural thing. So I guess I need to look into that. But that's okay. Yeah, thanks for the answer. So let's go from here. We have these guys. Double time, int array, X range, Y range, line color. I suppose what we should do is we should add in a start and end frame somewhere in the top here. Let me see, where did I put it before? Just to kind of keep with things. So we do, hey Leaf Eric, what's up? Draw array, write text, that's not what I want. Animate human, nope. Draw human. Draw human again. Okay, animate circle. Let me see. Where am I looking for? I'm looking for start frame, end frame here, animate line. That's what I'm looking for. So it looked like I put it right, yeah, right before double time. Oh, sorry for the yawn, guys. Man, I'm really sorry for the yawns. Okay, so let's go bar graph, and let's go ahead and have 2 additional guys here, start frame and end frame. And int end frame. And then we'll just kind of pop this guy down to the next line, because screw it. Okay, so now let's see, where do we need to start? We have something in here. You can make it work with little and both little and big endian. Fair enough. Okay, so what I need to do now is these guys should only draw up to, let's see, grow line. Okay, so these guys should only draw up to end frame here, and down here we should also do the same thing. 1 second. This will be end frame. There we go. Okay, so now what's next? Now we have to do the start frame stuff. So basically, anytime we see an animation current frame, what we should do is we should change this to, let me think. I suppose start frame. So let me go up, see how many times we have this current frame. We have current frame there, current bar, current frame. Okay, so it's only in the grow line, it looks like. Current bar. Okay, so what we should do here is change this to start frame plus I. 1 second. So let's do start frame plus I. Oh, I. There we go. And down here we do the same thing. Start frame plus I. So let's do start frame plus I. Plus I. Okay. And now I think at the end of grow line, so let's go up to grow line. I think, grow line. I think we already, let me see, void grow line. At the very end here, yeah, so if animation current frame is too small, as in we are drawing on a frame bigger than animation current frame, we go ahead and reset that at the end here. So that's good. Okay, so now what do we need to do? Let's pop down here. Let's see, so I think this should solve some problems. So let's go into rank quit. Let's do visualization test.cpp. Now what I want to do is I want to draw, oops, sorry about that, all of these guys, but I want to draw them on one particular frame, but I don't want them to draw for anything but that one frame. So what I want to choose is I want to draw everything on 50, and then I want them to be gone by 51. Let's go here, let's make that. 1 second. Invalid initialization. Okay, this is because vi Cairo visualization.cpp. Let's go over here to vi Cairo visualization.h, and let's see what do we have here. So let's go down to bar graph. Here we are, and let's go ahead and add in what we need. So let's go down here and add that in. 1 second. Bar graph. Yes, that's what I want. Go up here, and let's just go ahead and remove this guy and that guy. Go down here and paste that in, and add in a semicolon. Rank quit. Make that. Okay, this one seems to make, so let's run visualization test, and let's see what happens. So it seems to draw more than what's allowed. So let's go into the last mirage. Scroll down, so it should start on 50. And we should see, oh, we see nothing. Well, that's good. Okay. Let me see, what are we drawing out here? We have 50, 51. Okay, for some reason, we are counting upwards. See, we have 1,000 elements. Let's go and let's change a couple things real quick. So let's go into vi visualization test.cpp. And let's change this value to a 0. And let's make that. Now let's do Mirage. Oh, first we have to run it. What is it counting out here? It is counting out I. Must be. Okay, so let me go here. Right and quit. chirovisualization.cpp, pop down here. Okay, and I think I see the problem. We should actually here, instead of doing start frame press plus I, we should actually just do start frame here. And then down here, what we need to do is, let me see, start frame. We should also do, this guy should be animation current frame, like it was before. Yeah, animation current frame. Okay, let's draw this. Let's make that. Okay, now let's see what happens if we run visualization test. Yep, so they're all being drawn on frame 50. So now if we do frame 50 for the Mirage, 1 second, let's go to 50. We should see, yep, okay, so we see it on frame 50, but only on frame 50. Okay, that's good. We are getting there. So next what we need to do is we need to highlight a single bar in this, just one bar. Okay, that's our next step. But first, let me get a quick sip of water, and then we will go from there. So the bar, I think, we'll highlight in, I guess we'll choose the color we want to highlight the bar in. Yeah, that's fair enough. But basically, we just want to highlight one bar for, I suppose, a range of frames. Okay, so it's winter, right? And the thing is, I oftentimes do not have any type of air conditioner or anything like that happening in the winter because it's winter and it's cool enough that you don't need air conditioning, and because I live in Okinawa, I don't believe heat should exist. So, you know, I never use a heater. However, last night I had to turn on a dehumidifier, and I gotta admit, I actually really kind of prefer the dehumidifier on than off, even though it's winter, because, like, I don't know, I don't have a headache this morning, which is crazy because it's been like weeks since I didn't have a headache. So I don't know, maybe it's you know, correlation, not causation, but I find it weird that I have to have that thing on at all times, literally all times. If the dehumidifier is not on, I'm screwed. Anyway, let's go ahead and do the highlight bar thing. So basically we have frame animation, all the array values that we want here, the element that we want to cover, but also here what I need to do is I need to read in one more guy here, which is going to be int start frame and end frame. So let's do int start frame and int end frame. Okay. So now once we add these guys in, unfortunately, it means that we have to bring some stuff down a little bit. Sorry, a completely pointless story. Let's see, SD vectors, so let's bring that down here. So we're going to do std vector of int, and then we're going to do ampersand array, and then we want to bring this down here, and we're going to say color highlight color. Okay, let's go ahead and remove some lines here. Go down here, remove these guys. Okay, make sure everything's spelled right, start frame, end frame, highlight color, good. Okay, so now we should be able to highlight a single bar in the simulation. So I guess let's go ahead and do that, check to make sure it works. So let's go into vi chirovisualization.h. Where are we? Visualization.h. Okay, let's pop down here. And we have highlight bar, but we can go ahead and remove all these guys because who cares about them, right? Am I right? I'm not, I'm wrong. Okay, so let's go down here, add in a semicolon. And what do we have here? Frame animation, int start frame, int end frame. Yeah, this should be good. Int array, double x range, y range. I suppose in essence we could give it, nah, it's fine, it's fine. Okay, so what are we gonna do for the highlight bar guy? Well, in the end, we're probably gonna have to do the same thing we did before in terms of finding the max element. Now what we could do is we could go ahead and read that value in. Let me see. So we could do this in a number of different ways. So we could do this such that we read in the maximum value in y and the maximum value in x, and then we give it where, and then we give it positions to draw on. That's fine. But I think what I'm going to do is I'm just going to go in here and do it the kind of slow way, because again, we don't care so much about performance. This is just visualization, so I'm not so worried about this. So let's just go ahead and do exactly what we did up there. So first we need to find the maximum element, which I'm going to rewrite. So we're going to say finding the maximum element in our array. And we're going to pop down here, we're going to say int max. It's going to be equal to the pointer from std, max element, And then we're going to say array.begin and array.end. There we go. So that should be that. So now we have the maximum element. Now, what do we need from here? We don't need draw frames because draw frames are all going to be 1, right? So we just want to highlight a bar. We don't want to like redraw the bar or anything like that. So we're just going to say, one second, int draw frames. Let's see, time, animation, FPS, start frame, end frame, bot top. Yep. Okay, good. Good. So what's the difference between grow line? Oh, I see. There is a clear difference between grow line and animate line, but not that big of a difference. Okay, so what are we going to do? We're basically going to say that, let me see, what do we want? We want to say draw frames is going to be equal to 1, but did I even use draw frames? Let me see. I less than draw frames. Oh, wait a minute. For an I equals 0, I less than draw frames. 1 second. What do we do here? Okay, I see what we're doing here. So draw frames is actually going to be, let me see. Kind of unnecessary in this case. But that's okay. That is perfectly okay. So let's pop down here and let's just do it. So what we're going to say is we need to create a vector for the top and the bottom. There we go. And I think I need a comma in there because who doesn't need commas? Okay, so let's go down and let's go from there. So we have vector top, bottom. Now what we need to do is basically fill these guys in. So we're going to say bottom.x is going to be equal to, and this is where we need to use int element times x range divided by array.size, and basically grab this guy from above. So let's just go ahead and do that. There we are. Then we need to do the same for bot.y. And this is going to be equal to basically this guy. So I see no reason not to copy it. In fact, let's just copy all these guys. And let's just say array of element right here. Okay, so let's go down here and let's go ahead and remove 8 spaces, I believe. So let's do 8x. Yep. Okay, and finally we need to grow the line. So let's pop down here and let's do grow line. And it should be animation. Then we want, let's see, what's 0? 0 is the time in which we draw it. Oh, wait a minute. Let me think here. Is 0 the time or 0 the start and end frame? Let's go over here and let's do grow line. Time, start frame and end frame. Did I get these guys mixed up? Double time, start frame and end frame. I think I did. Let me see, bar graph. Shoot. I got these guys mixed up. So let's go ahead and go up here and let's put time before start frame and end frame. So let's put a double time here. Okay, and let's remove double time from back here. Let's go over here and let's remove, 1 second. Bar graph, that's okay. What I want to remove is, oh no, that's the one I do want to fix. So double time will go up here. 1 second, so we will do double time. And let me just go ahead and right quit this. We're not going to compile it, obviously, but that's okay. So we're going to go down here, and I want to do draw time in 0. 5051. Now let's go to car visualization.cpp, pop down here. We're going to say grow line, and we're going to give it 0 time. And then we're going to say, let's see, what do we want? I suppose start and end frame is going to be, so we're going to say start frame, end frame, and then we want to do bot top line color. And this is going to be highlight color. Okay, and that should do it. Let's go over here. We're going to quit, make that. Highlight color was not defined. Highlight. Oh, I misspelled highlight. Great. Higlight, guys. Higlight is key. Let's go over here. Let's do car visualization.h, pop down here, and change this again to highlight. Okay, now let's do make one more time. Okay, good. So it does seem to make. That is fantastic. So now what I want to do is go over here and let's do visualization test. Let's go ahead and create a new color over here. So we do the bar graph, and now what I want to do is do a new color. So I want to say, let's say color, highlight. I did it again, highlight. Gosh darn it, light color, there we go, is going to be equal to, let's just make it red, so it's going to be red, 0, 0, 1, and then we're just going to pop over here. So we have the highlight color. So now what do we need to do? We need to go ahead and do highlight bar. And this is going to be of everything we need. So let's go here, Cairo visualization.h, pop it down here, and we're going to need layers of, we can draw on the same layer, layer of 1. Then we need start frame and end frame. So this is going to be, let's say, from 51 to, I don't know, 80 or something, just 30 frames or something. Now what do we want? Array, X range, Y range, highlight color, and element, which we'll do as 1. Actually, let's do this as 100. Write this, go over here, right and quit. Make X range was not declared in the scope. Oh, 400, 300, I guess. Let's do 400, 300. Make that. Vector origin, let me see, is not used. What was it going to be used for? Oh, I guess we'll just comment this out. Make. Now we'll run visualization test. And let's see what we got. So it says up to 51. That's nice. Now let's do the last mirage. Should be right here. Here's 50. Oh, well, we highlighted it, but I obviously removed the graph. So let's go and let's add the graph back on. Okay, so let's change this so that this is on for, I don't know, maybe 100 frames or 50 frames, like that. Visualization test. Okay, now we're gonna do Mirage. Scroll down, there we have it. Okay, good. So we have it highlighted. I think this is good. This is exactly what I want. That's great. So now what do I want to do? Well, I think at this point we can move on to the next step, which is, let's see, we can go ahead and start working on our first sorting algorithm. Woo, super excited here. So this is going to be the BOGO sort. It's going to be the first one we do because it's the easiest one to do and implement and check and stuff like this. So it should be relatively straightforward. And then we'll move on to actual sorting algorithms tomorrow, which are going to be the two. I'll be using them during parsing mostly, so I expect to be significantly faster. Let me see. Only between my own implementations, but I'm planning on doing some against regular chars. I don't know how big of a win it will be against std string. As far as I can tell, they're all doing this optimization. Yeah, fair enough. Okay, so what are we going to do? We're going to do the stupidest sort ever today, which is BOGO sort. And when we finish that, I think we'll just go ahead and end today's stream. Again, it won't take that much longer, I guess. We're moving quite fast. But at the same time, I don't have too much more prepared for today. So I guess we can kind of chill and stuff like that for a bit. But that's okay. Anyway, guys, I hope you're having a fantastic day, by the way. If you're not, I'm sorry. If you are, I'm super happy. But anyway, if you guys have any comments, questions, concerns, anything like that, feel free to let me know in the comment section on the side there. And I will totally... I'll totally address that as soon as I see it in chat. Anyway, so what do I want to do then? We have basically everything set. So let's just go ahead and do our first sorting thing. So what are we going to do? Let's go ahead and right quit. And let's go back a couple directories. So cd, what are we going to do? It's going to be, I think, worstsort. There we go, ls. And let's go into vi worstsort.cpp. Okay, so we have these functions that I just kind of sat there a while ago. So let me go back, and then we're going to do worstsort. And now we're there. Okay, so we have these functions. Again, I didn't do anything to these functions. They're just there. So we need one more function, though. And that's going to be a function, a Boolean function to tell if the array is sorted. So we're going to say Boolean. Let's go here and let's say function. One second. Function to determine whether an array is sorted. So let's go here. And I wonder, is there an easy way to do this in C++? I don't know. I'm just going to do is sorted. And we're going to say we need an std vector of integers array. Okay, now one thing I do need to check, I need to make sure that, let me go into VI visualization, and then Cairo, and then Cairo visualization dot, let's do H, pop down here, let's see, what do we have for the array? Yes, it is a vector of integers. Good, just making sure I had done that for all vectors of integers. On plain string test, std string footprint is 32 bytes. I think local optimization is generally 16 bytes. What this does, however, is that std string bloats everything using it. Local optimizations only help if std string is used locally, but when it's used as a data member, it'll cause everything such as to bloat. Interesting. Man, I wish I knew more about like internal C stuff. In fact, I should probably do some of this, you know? I should definitely learn some of this. Maybe even as something on stream, we'll see. Okay, so let's go down and let's go ahead and comment this guy a little bit further by doing the following. Just kind of parsing things a little bit. So I'm going to go ahead and set this as main. 1 second, main. And then I'm going to also add something for the subroutines below. So we're going to have to put these again down there. And again, guys, I kind of like this structure. You guys have seen this structure before. I always do this structure where we have kind of everything defined up top, and then we have everything else defined under main. I don't know why I do this, but I've been doing it forever. And I guess I should put an S at the end. Oh, U. There we go. Go down here. And let's go here. Okay, so what are we going to do? The first function I suppose we should check is the isSorted function. So I guess what we'll do is we'll just kind of go through. Yeah, okay, so I guess we should do this. So we'll say while one value is less than another value, we just continue. So let's go ahead and create this function. So we're going to say function to determine whether array is sorted. So we're going to do Boolean is sorted. Oh my gosh, if I can spell sorted. And then we're going to do std vector int array. Okay, now I know that there are probably plenty of algorithms out there to check whether something is sorted or not. We're just going to do something really stupid, and we're just going to go by point to check to make sure that the value before is less than the value after. So what we're going to do is we're going to say, 1 second, int num1 and num2, and then I just want to go through and just say num1 is going to be equal to array of 0, and num2 is going to be equal to array of 1. Okay, then we go down here and we say for int I equals 1. Oh, actually, while, let's just do this. Actually, wait. Let's do a for loop. A for loop should still be okay. For, that was not for int I equals 2. Let's do 1. I less than, what do I want to do here? I suppose I want to do array dot size I++, and let's change this int to a size t. Okay, so now what we're going to do is we're going to say num1 is going to be equal to array of I minus 1, semicolon there. Now we're going to say num2 is going to be equal to array of I. Now we say, okay, so we go through this entire for loop, and I think we're allowed to do the following. So we're going to say if, what do we want here? Num2 is bigger than num1, then we can do the following, I think. Return false. Otherwise, can we just return true? Are we allowed to do this? Okay, well, let's check this just to see if it works. We'll run a test on this. But basically, the idea would be that we return if num2 is ever greater than num1. So I think this should be okay. We'll see. Maybe it's not. Maybe I'm just doing stupid faulty logic. But basically, let me put in a very quick comment in here. So we are checking, see if adjacent values are ever in the wrong order. And of course, there's much more efficient ways to do this. I get that. But I was thinking about also visualizing this. So this is an easy way that we could just kind of draw a, like highlight one color and just kind of do, like highlight a single color all the way through or something like this. Then there's no point optimize something that'll fit cache line as is for random access use if there's no better way use the rest of the cache line. Okay, so let's go up here and let's just go ahead and create some stuff. So we're going to go ahead and create an array. So we're going to do int array. Actually, what should we do? Let's go ahead and see. We could do a void init function to initialize our array, giving it a number of elements. Yeah, I suppose maybe it's best to do an std vector for the initialization here. Let me see. Is there any other time that we'll be using random numbers? Yeah, we'll be using with worstsort, but that's okay. So we have random already included here. Now, let me see. What do I need to do? I'm going to have to use a uniform int distribution. Ah, gosh, I always freaking forget about random numbers. Every single time I have to do random numbers in C, I always forget how to do it. Every single time. So let's just go ahead and just do all the initialization in main, and we'll kind of go from there. So first, let's go ahead and create a standard sorted vector, just to make sure our isSorted function returns true. So let's go ahead and do std vector, and we're going to call this array, and it's going to be of size, let's make it size 100. We're going to say for int I equals 0, 1 second, I less than 100, I plus plus, pop this down here, and we're going to say array of I, 1 second, I is going to be equal to I. Done. Got that one. So now we're just going to std cout if it's sorted. So we're going to do std cout is sorted of array, and it should return true if num2 is greater than num1. Actually, that's always going to be true, so this should be less than. Yeah, okay. So let's go ahead and write this, go here, make that. Okay, array, let me see. Visiting template argument for array, of course, because I forgot to put this as an int. Let's go here, int. Okay, that one seemed to make. Now let's go ahead and run worstsort 1. Okay, so now what I want to do is the opposite. So let's say I less than 100. Let me see. I 100. I, let's see, greater than 0. I minus minus. Make worstsort. That one also returns 1. That is a little weird. Let me see. So we return false. Oh, I see what I did. Let's see. I want array. Let's go back to what we had before. Array equals 0. Array less than 100. I plus plus. Now we're going to say I is going to be equal to 100 minus I. Make that. Now we're going to do worstsort. Okay, good. So that one returns 0. So we do return what we want. So we have, if we're going one way, we are sorted. The other way is not sorted. Sure, in some sense, it is still sorted the other way, but this is fine. This is fine. So let's go ahead and initialize these guys randomly. So let's go here. Random initialization of array. Okay, and let's see, what do we need to do? I'm going to go ahead and just do, I suppose, just a random uniform int distribution between 1 and 100 or something like this. Organizing code, most important thing is to get final pointer solved as early as possible before using it. Got it. That's for Gustron, I think, though. Okay, so this is fine. So we're going to do random initialization of the array. Okay, and since it's a vector of integers, I suppose we just I don't know, have a whole bunch of random integers, and then we sort those guys. So what do we want to do? I suppose we need to do... Gosh darn it, I always forget every single time. Let me do ls backup directory real quick. So where did we use random numbers last? Every single time. Every single time I have to use random numbers, I always have to look this up again. So we have geometrical optics. We used random numbers there, but I don't think that was the last time we used it. Tunneling viral video. Let's go to viral video. 1 second. Viral video. And let's see, what do we have here? I guess viral video .cpp. Okay, so let's do random. There we go. Okay, something like this is probably what we need. Okay, so let's do over here, static std random device random device rd. Then we need to create a generator, so we're going to do static std Merlin Twister 19937, and this is going to be called generator of random device. There we go, something like this. Now what else do we need? We need to do std uniform int distribution, and this is going to be of integers, and it will be, what do we want to call it? I suppose we could call it I'm just going to call it dist, because there isn't any reason to really make this crazy. So we're going to do 0 to, let's do 1,000. I suppose the bet higher this is, we can do 10,000. It doesn't really matter much. Okay, we're not going to go higher than 1,000, but I think it's good to do it this way. Okay, so now we have our uniform int distribution, and that should be that. So now, anytime we need to use this, all we need to do is just say array of I is going to be equal to, and that was not what I wanted to make it equal to, distribution of generator. Okay, let's write this, go here, print quit, make, and let's run, what do I want? I want to run worstsort. Okay, it's obviously not sorted. That's probably what we want. Okay, so now we have to initialize everything for the drawing of this vector. So let's go through here, and let's just go ahead and do things a little bit differently. Let's go and say int resolution equals 100. Let's go down here and let's change this to resolution. Ooh, no, let's not do resolution. Let's do numbar. Numbar sounds like number. Numbar, never mind. I'm just bad at life. Numbars. Okay, let's go down here. Array of I, and this is also gonna be numbars. Okay, so now let's go ahead and initialize everything. And I suppose we can do this up here. Yeah, let's do the initialization of the Cairo stuff up here. So initializing Cairo stuff. Okay, so now we have to do all the initialization of the Cairo stuff. Let me see, we've done this just yesterday, so I'm going to take that from yesterday. Oh my gosh, I'm sorry guys. Cairo visualization test. Oh, I see. I'm calling the executable. I need to call in vi, and then visualization test.cpp. Okay, so basically initializing this guy in the same way as before. Passing 0 to gen. You might want to, yeah, sure, that's fair enough. I mean, but that's just setting a random seed, you know, so. But that's okay, yep. I could do that. Okay, so what do we do here? Cairo stuff. Let's go ahead and let's go from there. Okay, so what do I want to do? I want to do basically this. I think that should be okay. So let's just grab this, paste it here, and we should be good to go because I am lazy and I shouldn't be this lazy, but I am. So we're gonna do layers of 0, background is fine. Okay, so now we have this. See how it is sorted? That's okay. So let's go ahead and output the array now. So we should do, let's see, bar graph. Yeah, so we should just be able to do bar graph. So let's do bar graph of layers of 1. And then we're going to do, I guess we're going to do from 0 to number of frames. Or descending order, opposite to sorted order. Yeah, so I see what you're saying. Let me see. I think. So we can look into the other sorted order too. Yeah, that's fine. We can do that. I just kind of wrote something really quickly. But yeah, we should definitely have that other case in there, I guess. So I'll take a look at that in a bit. Let's go ahead and get the other sorting done, and then we'll work on that in a second. So we're going to 0 to number of frames. Then what do we want here? So we want the array. Nope. We want, I did this wrong. We want 0 num frames, A. Okay, but let's give this guy some time. So let's go ahead and say we want to draw it in their 100 points. So let's give it, not a second per, but let's see. Let's give it 100 frames. Yeah, let's see what happens if we give it 100 frames. So now we're going to say number of frames. Okay, now we need to do array. Then we need animation.resolution x and animation.resolution y. And then we need the line color. Okay. Oh, there isn't is sorted? Crap. I didn't know that. I made my own, but if there isn't is sorted, let me see. Let's do is sorted. 1 second. C++. Okay, yeah, we'll just use this then. No reason to make your own. I'll leave the function in there though. Let me see. Is sorted. I just want... Let's see what happens if we return this. So let's do std is sorted. And I think this should be okay. What do we need to read in for this? I think algorithm might need to be read in. Let's go up here, read in algorithm. Algorithm. Okay. Let me see. So now we'll do std is sorted, and this should be okay. So let's go ahead, go over here, run quit. Let's make this. Okay, good. So everything's broken. That's fantastic. Okay, so layers, int layers. Let me see. What do we have here? Takes an iterator pair. Oh, okay. Okay, so let me see. Is sorted. Okay, so I guess we just want this. So is sorted, std begin array and std end array. Std end array. Okay, that should be okay. So what do we have here? 3 arguments. Let's go here, write this, go over here, make that. Okay, so frame is not declared in the scope. What? Just apply the same comparative sort data in order. I am currently, so what we're doing while sender is we are working on basically simple sorting algorithms, just for fun. The idea was that we want to use the absolute worst sorting algorithm possible, which by the way, I now have. 1 second. Let me just go ahead and give you guys this. Here it is. I don't know if it was ever actually published anywhere outside of the archive. It was just on the archive. And I thought it was kind of neat. So I figured, hey, let's just go ahead and do the worst sort for 2016, which, you know, a lot of people say is the worst kind of year. So let me see. Frame is not... Okay, this is because I'm not including what we need. So let's go down here. Let's do include. And I guess we need to do visualization. Cairo, and then Cairo visualization. .h. Let's go over here, and let's go ahead and make that. Okay, animation was not declared in the scope. That's fair enough, because this would be layer of 0 for both of these guys. Yeah, it's been, I don't know, it's been interesting. So let's do layer, is there an S? There is an S of 0. And let's do the same thing down here. Layers of 0.resolution y. And let's make that. Seems to make just fine, so let's now run worstsort. And 3,000, dog. I think that's wrong. 31, 61, 91. Why are we hopping up? What? Let's do Mirage. Oh, I didn't draw the frames. So I guess I need to do that, don't I? Let's go over here. Let's see. Visualization test. Yeah, draw layers. That's all it is. So let's go down here. Let's do draw layers. And we'll do layers. Make. Worst sort. Then we'll run Mirage. Let's see. Well, this seems to be doing something, but it seems to be doing it way too slow. Okay, so let's see. What do we need to do? I guess it's worth being kept a secret from unwatched public. A study about how badly someone can potentially screw up is dangerous, so someone is bound to do worse. Yes, except that this one is, it's actually quite bad. Like, the order of complexity is actually, let me see, they have it in here. Where is it? It is, where is it? Here it is. Okay, so they have sigma notation, and it actually has a summation in sigma notation. So let me scroll in here. Like, you can make it variably bad. It is as bad as you want it to be, and it is provably that bad. So it's just one of those things that it's like, well, okay, like, sure, you could make something that is potentially worse, but this guy can always just say, well, we're going to make it even worse by changing the way that we're doing the sorting. So, like, this particular complexity notation is basically like, it might not be the absolute worst sort ever, but it is definitely, it can be the worst sort ever if you run it to its optimal extent. Like, basically, it will not converge. Like, you will not find a sorted list in the end. It does it in a very stupid way. It's just kind of a fun little thing to do, and we'll kind of describe it probably tomorrow. In fact, probably definitely tomorrow. Probably definitely tomorrow. Yep, that's how you do it. So let's say instead of 100, let's give this guy 1. Go here and make that. Now let's go into, let's see, worst sort. Yep. So now it's all being drawn on frame 1. Okay, so let's do Mirage. Okay, so this just kind of randomly generated the data, but that's not what I want either. So let me see, how about I give it 10? Okay. Mirage. Oh, is this doing the same thing? Let me see something. Oh, I forgot to do worst sort. Now let's do Mirage. Okay, yeah, this is fine. I like that. That's okay. So it seems to work okay. Lost Center, are you planning on uploading today's stream to your YouTube channel? Yes, I am. I have been uploading the streams. However, something happened on YouTube lately, and I was going to see if they would fix it before putting more videos up on my second YouTube channel. And what basically happened was, beforehand, what I would do is I would put out a video on the second YouTube channel, and then before actually making it public, I would go through and I would remove the first 5 minutes. Like, I have this little card that says the stream is starting soon, and I wanted to remove that before moving any further. However, YouTube no longer lets me edit my videos in this way. So because of that, I feel like I was hoping that I'd be able to do the editing one more time, but I don't think I'm going to be able to. So I might as well just kind of put all the streams up again. And I kind of have kept forgetting, I kind of keep forgetting to do that. So I've got a couple of videos of backlog that I need to put up. But yeah, I have the last one. Actually, I have all of my streams on YouTube, just not all of them are public. So I'm hoping to make this one public. We'll see. Sorry about that, Lost Center. I know that it's probably quite annoying that it's been a while since I put videos up on that second channel. So we'll see how that goes. Okay, so we do the draw bar graph here. Okay, so let's go ahead and do the first sort because it's like stupidly easy, and that's going to be the BOGO sort. Really easy. All we do is we just randomly like redraw the bar plot all the time. Just redraw it and redraw it and redraw it again. Okay, so let's do it. So we're just going to do void BOGO sort, and all we need is the integer array. In fact, do we even need the array? Yeah, we do. The big omega? Yeah, that's fair enough. Appreciate all your streams. I haven't had time to watch live stream in a while. Thanks. Yeah, not a problem. I'm really sorry about that. I have just been a little bit late on the YouTube channel stuff. I'll, again, be more, how do I put this? I will be more consistent with it from now on. I was just kind of inconsistent with my streaming schedule, which kind of made me inconsistent with a number of other things. And there were certain streams that I didn't want to put on YouTube, since it gives the lower bound instead of the upper one. So the algorithm is either that bad or worse. Yeah, fair enough. So, yeah. Okay, so let's go ahead and create the function for BOGO sort. Pop down here, and let's go ahead and do, I suppose, what we need to do. So, okay, so we're going to say function to sort array based on BOGO sort. Okay, so we're going to say, what do we have here? Do we actually return anything? I think it's just void. Yeah, I think it's just void. So G down here, so we're going to say void. Well, if I can type anything, let's go down here, void BOGO sort, and we're going to do std vector of, I don't know what I was trying to spell there, but it was not std. That was closer, of integer array. Pop down here. Good. Okay. So now what do we need to do? We have void BOGO sort here. Basically, BOGO sort is relatively simple, right? Like, all we do is we just randomly jumble up the array again and again and again and again and again and again and again until eventually we have a sorted array, right? It's a really stupid way to do sorting. It's obviously not optimal, and there's actually no way to put big O notation to it because, like, well, is there a way? What is the big O notation of BOGO sort? Is that a thing? I thought it wasn't because it uses random numbers. Does worstsort use a randomized algorithm? No, it does not. Worstsort uses, so what it does is basically it says, in order to do a random search, you have to do some sort of permutation of all of the other values. And so what it does in order to find this permutation is it creates an array for the permutation, okay? And in creating that array for the permutation, it has to sort that array, right? So basically the idea is that you create an array to sort the other array, and then you sort the array that is supposed to sort your original array. And then in order to sort that array, you create a new array. So basically, like, you have your initial array, you create an array to sort the initial array, and then you create another array to sort the array that you just made, and then another array to sort the array you just made, and you keep creating new arrays to continually sort. And so basically, like, you can make it as bad as you want by just cutting or changing the threshold here. And that's kind of how it does, or how it happens. So BOGO sort, what do we need to do? Well, basically what we need to do is we need to create, like I just said, some sort of permutation of all of the different values we have in our array. So we have 1 to array.size, and we basically need to jumble all these guys up. So I suppose, let's see, how are we going to actually do this? I have to think. I didn't really think about this before doing the stream. I maybe should have now looking at it, but I didn't. So that was my bad. And what else do we need in BOGO sort? I think, I think we should initialize the Cairo stuff in each of the sorting, functions, I think. Yeah, maybe that's the best way to do it. Or should we have the Cairo stuff outside? I think we should probably have, oh yeah, sorry, I meant to pass it as a reference. In fact, for all of these guys, I meant to pass them as a reference. I thought about that at one point and then I just forgot. Okay. Oh, I can just use shuffle? Oh, I didn't know there was a shuffle. Dang it. That makes everything easy. Let's go here. Okay. So we can just do that then. And let's just go ahead and add in the BOGO sort. In fact, all of these guys, let's go ahead and add in a frame anim to the top of each of these guys. So let's go here and let's do frame ampersand anim. Okay, so we're gonna do the same thing here. Here. But we don't need it in is sorted. Okay, so now let's go down to BOGO sort, and let's just go ahead and do this one, because apparently there's a shuffle, which makes this, like, kind of trivial. So let's just go down here and let's do it. Shuffling, everything, until we have a sorted list. And so what I want to do for this one, because this is going to take forever if we have 100 elements, I kind of want to just do it with a smaller number of values here. So let's go down here and let's do while. I suppose we should do this is std is sorted, and we will do std begin. I suppose we do it the other way. Can we do it the other way? Let's see. Array.begin and array.end. Pop down here. Okay, so what I want to do then is, yeah, this should work. I guess we'll do std shuffle. If you want to implement shuffle yourself, you can implement a Fisher Yates shuffle. Yeah, we could do that, or I could just use shuffle. It's not that big of a deal. I mean, as long as people get the idea. So let's see. We'll do shuffle, and yeah, it might be useful to know. You're right. So array dot begin, and then array dot end, and then generator, which we need to read in. Okay. So the generator, I think, needs... No, that's okay. So now let's go ahead and set up the random numbers. So let's do... I believe it has to be a uniform int distribution like we had before. So we can probably just grab what we have here. Yeah, we can probably grab what we have here. So we will do array.size. Okay. So now what I want to do is... Let's see. We have this guy here. Okay, so I think this is probably okay. Let's see. std shuffle. You don't need the distribution. Oh, you're right. Obviously, because we only call the generator in shuffle. And I guess that makes sense. It probably knows what we need for the generator. Okay, so what do we do here? Random device RD, std Mercine twister. I always call it Merlin when it's Mercine. Random device. Sure. Okay. This is fair enough. So we just keep shuffling and then we're good to go. So now what do? We have the while loop. We have is sorted. Okay. So I guess what I want to do here is I want to change the number of bars from 10 to, or 100 to 10. I think 10 is probably doable. Let's go ahead and make this. Okay. And let's see. What do we have here? While std is sorted, expected an additional guy. Yep. That's fair enough. Let's make that. Okay, then we're gonna do, let's see, worstsort. Do quick mirage. Let's see what it looks like. It should still be fine. Yeah, okay, this is fair enough. Good. So now we just have to do the sorting, and let's do it. So we're gonna do BOGO sort, and then I want to just kind of draw these guys on one frame each. I think. Yeah, I think that's okay. We'll do one frame each. So what I want to do then is go down here, do animation current frame. Let's do frame anim, and let me see, did I pass them in by reference up here? Sure did. Good. So we're going to do animation.current frame plus plus, and then I basically just want to do bar graph of the following. So we're going to do animation, then we want to do the next one is time, so we're going to do 0. Then I want to do, I guess, animation current frame. And I suppose we want to do animation.current frame plus 1. Good. So what's the next one? We want array. And let's see. So if we do shuffle of the array, that should be okay. And now what do we want? We want resolution X and Y. So we're going to do animation.resolution X. And animation.resolution Y. And then we need line color, which we will define up top as, I suppose, white. So we'll do color, line color equals, and let's just make it white, so it'll be 1, 1, 1, 1. Something, come on, oh my gosh, 1. Okay, good. We're done. So we have the line color. We do the bar graph. We give it 0 time to draw. We give it only one frame in which it exists. And I think it should be okay. So now let's go up here and let's not draw the bar graph here. Instead, we should do... yeah, let's put them here. Instead, we should do BOGO sort. So let's pop down here. No, I just made it actually just a second ago. So, but it basically just draws all the bars like we had before. I made it yesterday, I think. So we should have that, and that'll be up on YouTube today. There's always a bit of delay between Twitch and YouTube. Unfortunately, it is bigger now than it's ever been, so that's kind of an issue that I need to fix. But yeah, so basically it just draws a bar graph like we had before. So if we go over here, it draws these values here. So that's what it does. Okay, so what do? We have this, so now let's go ahead and do a BOGO sort. So let's do BOGO sort of the following. So we want to do layers of 1, and let's do array. Let's go here, let's make that. Okay, line color unused. Right, I was just wondering if it's probably something like boost. No, it's not. So we kind of did all the visualizations ourselves for this kind of thing. Line color is unused, that's fair enough. So let's go ahead and do worstsort. Okay, segmentation fault, fantastic, great. Okay, so maybe 10 is too many. Let's go up here and let's try 4. Make. 1 second. Worstsort. That one seemed to do something. Okay, let's do Mirage. Oh gosh. I don't see anything being drawn. Crap. Okay, so we do bar graph. It should be on individual frames. Oh, I know the problem. Let's do Mirage here, but let's go back to the first frame. Ah, here we are. Good. Okay. So here we have it. So we have each of these guys randomly being distributed until there. Okay. That's okay. Now, one thing that I do find a little bit weird here is that these guys are both the same and these guys are almost the same when they shouldn't be. Okay. So let me think here. We need to figure that one out. So the distribution, if 10 segfolded, I mean, I don't know. Let's see, what are the chances of us randomly encountering, the reason it segfaulted was because we ran out of frames to draw on, right? So that was the reason it segfaulted. And so 4 factorial, what is 4 factorial? So 4 factorial is going to be 4 times 3 times 2. So this is going to be 12. Yeah, so that should be okay. Let me see. But 4 times 3 is going to be 12. And then times 2 is going to be 24. So let me see. Yeah. And how many frames did we actually draw on? I think we drew on like 40 something. Yeah, we drew on like... Yeah, we drew on 43. It's a lot of iterations. I thought it was 1 over n factorial. 1 second. Yeah, so I thought it was 1 over n factorial for the for this guy, but maybe I'm wrong about that. So what we might do then is we might say, because in the end, if we have a large array, BOGO sort is just not going to work. You know, like, we're going to run into an issue. So I guess while we're less than number of frames, yeah, how about we do this? While animation current frames is less than number of frames. Okay, that's what we need. What was 1 over n factorial? That should be the chances that randomly shuffling the array will give us a sorted array. So there's 1 over n factorial chance that it will be actually a sorted array, I think. Unless I'm thinking about this incorrectly. But that should be okay. Let me get a quick sip of water, and let's think about what we want to do about this situation, because clearly we're going to run out of frames a lot. Like, that's just the nature of BOGO sort. We're going to run out of a lot of frames. Let's do it again. Let me see how many times it takes this time. Worst sort. 14. Okay, that seems fair enough. Worst sort. 87. Okay. 5. 11. 7. 54. Let's take a look at this one. STD next permutation for that sweet n factorial complexity. You could implement a deterministic bogus sort with STD next permutation. Let's see, how would we do that? First of all, let me take a look at this. Mirage. Yeah, we might need to do the deterministic bogus sort. Yeah, that might be the best way to do this. So in the end, we do have a sorted array at the end there. That's nice. Yeah, we should do the deterministic bogus sort. Okay, so how do we do this? The next permutation for that sweet... Look, I'll be honest. We're looking for the worst sorting algorithm, right? So bogus sort's perfectly fine. So let me think here. What would... Yeah, okay. Oh, literally, we just do that? Okay. Okay, so the reason next permutation makes it deterministic is because in this case, what we're doing is we're just shuffling the array, or beforehand, what we were doing is we were just shuffling the array again and again and again and again. So it could be that we basically shuffle the array in the same way twice, or 3 times, or 4 times. But with the next permutation, what we do is we cycle through one permutation at a time. So we go, we permute, 1, 2, 3, and then the next time we do 1, 3, 2, and the next time we do, so we step through it. So we never repeat a permutation. So this makes it deterministic because it means that all we do is we check all permutations rather than randomly choosing the permutations one at a time, right? So this is why it would go from non-deterministic, where it's just completely random, to deterministic, where we step by step move through. Okay, so I guess if we can remove that, does this actually make? If that makes, I'm super surprised. Holy cow, that makes. So let's do, yeah, never repeat. That's exactly right. Let's do worst sort. Took 17. Worst sort. Took 11. 20. Okay, but is this fair, right? So n factorial, in this case, is going to be 4 times 3 times 2. It's going to be 24. So we should never be over 24. That's how this is. So let's see, 5 factorial. What is 5 factorial? 5 is going to be 5 times 24, which is going to be 120. Okay? 6 factorial is going to be... Okay, let's do 5 factorial then, just to check some things. So let's change this to 5. Let's go over here. Let's make that. Now let's do worst sort. 5 doesn't seem right. 3 doesn't seem right. 73, that seems right. 54. 76. Okay, so let's take a look at this one then. Mirage. Okay, so we have our 5 numbers here. Go back to the start. Okay, good. So we should just kind of... Yeah, okay, where's the last one there? There it is, there. Okay, yeah, so it's sorted in the end. Crazy that it's sorted at all, but that's fine. BOGO sort, man. Okay, so what do we want to do next? We still have 30 minutes. We could go ahead and implement bubble sort, but I kind of forgot which one bubble sort was. I know there are a couple of different sorting algorithms here and there, but so let's go ahead and remove the generator here. So remove this guy here. Juju. Why am I saying juju? That doesn't make any sense. What am I doing with my life? Okay, so we have here line color there. BOGO sort's done. So we have 2 more sorts that we need to get done, which will be bubble sort and worst sort, and then... Are we really done with this? Is that all we need to do? Wow, that's kind of crazy that we're this close to being done with this. I thought this was going to take more days, but it's literally only took 3 days. It's only taken 3 days, or will have taken 3 days. One thing I want to point out is for the next simulation I want to run, let's see, I would like to, on my YouTube channel, take the month of January 2017, and I want to go through, and I want to basically do a couple of things. It's when the smallest largest bubbles on top of everything to top every iteration? Yes, that is correct. I mean, that's why it's called bubble sort. What is the reason for using bad sorting algorithms? There is no reason outside of just pure curiosity for how these algorithms work. That is, you know, for the most cases, if you want a fast sorting algorithm, use like quick sort, or I guess merge sort, I think is also quite quick. Or you can just use std sort for C++, or really just sorting algorithms are very well known. Like, chances are, if you're running a programming language that is a standard programming language, C++, Julia, Python, Fortran, MATLAB, anything, their sorting algorithm will be better. And swap them if they are out of order. Bubble sort is when you compare two adjacent elements and swap them if they are out of order. Yep, okay. So let me see. I have to remember. Okay, let's just go ahead and get bubble sort started then. So what we're gonna do is we're gonna pop down here. We might as well, yeah, whatever. Function to sort. Gosh, how can I not remember bubble sort right now? I've done it before. Okay, function to sort array based on bubble sort. Let's pop down here. So let's do void bubble sort. I didn't actually expect to get this far today, so this is kind of why I'm a little bit enum. Std vector of int, and we're going to do ampersand array. Okay, pop this down here. Good. 2 nested for loops. Yeah, fair enough. Are you going to implement the various ones? I'm going to implement one bad one in particular, and it's called worstsort. It's just a very interesting sorting algorithm that I saw that I thought would make a cool video. It's not going to be like a super long YouTube video or anything like that, but hey, that's okay. So let's see, we have bubble sort. Yeah, okay. So let's see, we'll do a for loop. Sorry for the yawn, guys. Okay, but we got as far as I wanted to get today, which was through BOGO sort. Then I wanted to do bubble sort and worstsort tomorrow, and that was what I wanted to do. However, this might not be the longest YouTube video. It might be an incredibly short YouTube video in the end. I guess that's okay. You know, it doesn't matter that it's so long. Yeah, it should be okay. Yeah, what's the worst? Yeah, who cares? No one cares about YouTube video length. Okay. So, guys, what I might do is I might just go ahead and end the stream here, do the bubble sort and BOGO sort tomorrow, because bubble sort and worstsort tomorrow, and I realize we're ending like super duper early. I get that, but at the same time, you know, we got as far as I wanted to get, so I'm not so worried about it. I don't want to like embarrass myself implementing a simple sort algorithm, but maybe we could just do it. Yeah, let's do it. Bubble sort. This is me being an idiot. Okay, what do we have here? We say procedure bubble sort, optimizing bubble sort. Ooh, that looks neat. Oh, this is, yeah, random array, and then what we do is yeah, okay, fair enough. Okay. Let's take a look at this code, and let's see what we got. So, procedure bubble sort. Length A. Swapped equals false. For I equals 1 to n minus 1 inclusive, do, if a minus 1 is greater than a, then swap a and swapped equals true. And if, for. If array I is greater than array j, then std swap array I and array j. Does that actually, will this do it? Let's see what happens. Let's just do it. Let's do it. Okay, so what are we going to do? We need 2 for loops then. So let's do, we have our array, so we're going to do for int I equals 0. Let's do size t's. And then we're going to do I less than array dot size. We're going to do I++. Pop this down here. Now we're going to do, one second, for size t. J equals 0. We're going to do j less than array dot size. Then we're going to do j++. Okay, so now we're going to say if array of I greater than array of j is, I didn't actually know there was an std swap, so that's quite interesting. Learning new things every day. Then we're just going to do std swap. So we do std swap. This is probably not going to work anyway. Array of I, array of j. I don't think that's going to work. That seems wrong to me. Oh, no, I guess this is fair. Yeah, let's see what happens. Then we're just going to check to see if it's sorted in the end. So let's do is sorted. So I guess we're going to do std cout std is sorted array dot begin array dot end new line. Let's make this. Okay, so it seems to run at least. Let's go up here to the top, main. Okay, so let's go down here. We have main there, BOGO sort. And let's just go ahead and change this to, instead of BOGO sort, we want to now do bubble sort. And let's do layers of 1. And then we'll do array. Make that. Go to worstsort. Well, returned false. That's good. G down here. Okay, so let's see. If array of I suppose what we can do is we can just go ahead and do a bar graph of each of these guys, just because why not? So let's do SD swap. Yeah, let's just do this. So we're gonna do bar graph. So we'll do bar graph of animation, and then we want it to draw in 0 time, and animation dot current frame, and animation dot current frame +1 array. Pop down here. We're going to do animation. Once again, animation dot resolution x, and then we're going to do animation dot resolution y, and then finally line color, which we'll define up top. Okay, let's see what's actually happening underneath. So let's go down here and let's do what do we have here? Color, line color. It's going to be equal to 1, 1, 1, 1. Make this. Okay, now we're going to do worstsort. Mirage. I think I forgot to do something. And that would be, go down here and do animation current frame ++. Oh, I also did something else wrong. Let's do a yank 3 yank. And let's pop down here. Paste. Let's go ahead and do D, 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 D. Happy Hanukkah? Hey, happy Hanukkah. Let's go here. Write this. What is happening? Write this. Go over here. Make that. Oh my gosh, what am I doing wrong with my life? Worstsort. Here. Okay, so we go up to 25, which is fair because that's 5 times 5. Now let's do Mirage. Let's go back to 1. And let's see, what do we have here? Here's 1. So we do... Oh, are we sorting it incorrectly? Yeah, it's being sorted the opposite way. Okay, so let's do these. Make that. Then we do Mirage. Oh, oops, I need to do worstsort. Then we'll do Mirage. And it is apparently sorted correctly, so this is nice. Let's go see what we got. Yeah, it looks sorted in the end. Okay, so there we also have bubble sort done. Great. I think, unless I did this wrong. I'm not sure. I need to, okay, let me get back to you on that one, Lost Center. I mean, we will see. Let's see. So in the end, let me look at what bubble sort is over here. So basically all we're doing in bubble sort is we are swapping the different elements, right? So let's see, pseudocode implementation. What do? We say procedure bubble sort, swap inclusive, swap if AI is less than A. Hey iCare, thanks for coming in. So we do swapped equals true to have n adjacent swaps. Yeah, that's basically what we're doing, right? I mean, we are swapping here, right? So we're saying if I and J, oh, it's not adjacent, are they? They are not adjacent. Let me see. Performance bubble sort is worst case average complexity of ON squared. Let me see. Yeah, okay, so let's see. Bubble sort is worst case and average complexity of ON squared. I need to look this one up. I'm sorry, guys. I forgot the actual implementation of this guy. I mean, I know I've done it before, but I just completely forgot it. Rabbits and turtles? Oh, that's good. Oh, I see what we're doing here. So basically what we need to do is we need to go through this. I don't think this is bubble sort at all, actually, what we just did here. What we need to do is we need to go through two different sorts here. Let me think. And we should do... Let me go ahead and comment this out because it does actually work. So that's something. Let's go down here. And let's go here. So what I want then is I want to do for size t. What sort is that? Mapping the heavens? Radical scientific ideas that reveal the cosmos? Was that a copy paste, or was that another sorting algorithm that I need to look into? One thing I want to point out though, there is the intelligent design sort. Sort, which is amazing. In case you haven't seen it before, here's the idea. I think I may have linked that yesterday too on accident, but yeah. I'm not sure what sort we just did, actually. But I think you're right in that it's not bubble sort. So let's go through and let's fix that one up. Worst case are average of ON log n. Even other n squared sorting algorithms such as insertion sort to have better performance than bubble sort. Therefore, bubble sort is not practical sorting algorithm when n is large. That is totally true. However, we're not worried about the optimal case. So let's do size ti equals 0. Hey, Slayer Darth. I less than array dot size. Then we'll do I plus plus. Okay, so let's see. What are we actually going to do here, guys? I suppose. Yeah, so we go through, sort all of the elements, and then what we do is let me think. I know, right? Can anyone advise some Wi-Fi issues I'm having on Ubuntu? What is the issue exactly? I don't know if I can help, but you know, I've used Network Manager a good bit before. Okay, so for size t I equals 0, I less than array.size I plus plus. So what are we going to do? I guess we go through all of them and we sort them all. And we have a second loop here. So we say for, let me think. Bubble sort is probably worth forgetting. That's totally true. Again, we're working on the worst sorting algorithms possible, not the best. So basically what I wanted to do is I wanted in the video to be like, here's bubble sort, it's pretty bad. Here is BOGO sort, it is probably the only thing worse than bubble sort, except for worst sort, which is even worse. So we have Wi-Fi extender upstairs and transmitting 2 GHz frequency band. Okay, so what do we do here? Let me just go through and let me take a look at this again. So rabbits and turtles, that doesn't really help me that much. Okay, so procedure bubble sort. N equals length A. Repeat. So swapped equals false. For I equals 1 to n minus 1 inclusive, do if ai minus 1 greater than a, then we swap the two. And we set swapped equals true. And if, and for, one second. So the inner loop will have n minus 1 adjacent comparisons, and the outer loop will have n iterations of the inner loop. Yes, that is true. One second. We have Wi-Fi extender upstairs by transmitting on 2 GHz frequency band. But are you working for Dell? Oh. Okay, so how about we do... Let me see. You know, I said this a second ago. Let me take a second, or let me take some time outside of stream to relearn this. I know it's super simple and obvious and stuff like that, but let me do that. So let me take some time to relearn this outside of stream. I'll come back tomorrow. We'll re-implement this. I apologize, guys, for the delay there, but that's how it goes sometimes. So anyway, guys, at this point, I think I'm going to go ahead and end the stream. I realize some people just came in. I care, and let me see, Slayer Darth, for example. But we can carry on that conversation on the Discord chat. Let's go here. So feel free to pop in there. But I think I'll go ahead and end the stream here. I guess that's why they don't like bubble sort. Wait, why don't they like bubble sort? Bubble sort is inherently slow. Like, this is true. Like, when compared to other sorting algorithms, you can pretty much always find a better sorting algorithm than bubble sort. Almost always. In fact, pretty much always. So bubble sort's the one that you never really use. It's there, but you never really use it. But anyway, guys, I'm going to go ahead and end the stream for the day. Have a fantastic day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys next time for the next episode of Simulaos, when we implement both bubble sort and hopefully worst-sort. That's the hope. And we will kind of go from there. So at this point, I think I'm going to go ahead and commit what we have to GitHub. I think I'll just go ahead and comment this guy out. So let's go ahead and do a DD here. Yeah, let's just go ahead and commit what we have to GitHub right now. So let me go ahead and do a run quit. Git status. 1 second. Dot. And let's see. None of these guys have been added yet. So let's go ahead and add them. So let's go ahead and do git add, make file, and worstsort.cpp. Let me do an ls real quick. And good. So let's pop back a directory and another directory to visualization, Cairo, and let's do a git status dot, and let's add all these guys. Git add, make file, Cairo visualization dot cpp, Cairo visualization dot h, visualization test dot cpp, and let's go ahead and do a git status real quick. Okay, so it looks like, I know that's a lot of files, but it looks like we have everything modified and added in. So we should be okay to go from there. Can you stream about sorting large text binary data? I don't know very much about this, but I can look into it maybe. So I need to kind of learn about that myself. So let's see, we have the make file. New file. Okay, good. So it looks like we're all fine here. So let's go ahead and do a git commit -m. Updating, let's see, how about updating Cairo visualization? Adding skeleton for worst visualization. Okay. That meant to be git. Okay, now we'll do git push origin master. I have done limited sort algorithms that basically use CPU and in-register swaps with bubble sort like... Oh, interesting. There's absolutely fast way to do it. Load everything to the register, swap registers right back. Always constant time. Huh. Well, that's interesting. So we'll take a look at that then. Yeah, definitely should take a look at that. Anyway, guys, this is now available on GitHub. 208 line insertion, 26 deletions. That's pretty good. But anyway, guys, that is it for today. I know I already signed off, but I'm going to sign off again. So again, have a great day, night, afternoon, evening, morning, whatever time it happens to be your time. And I will see you around next time for the next episode. Thanks again for coming in, guys, and I will see you around. Bye, guys.